So for the next example, same instructions, which mean take the derivative, set it equal to 0, factor, solve, make my sign table. Once I'm done that, list any maximum and minimums, and list the intervals of increasing or decreasing. Everybody give it a try. So if you're checking your work, take the derivative, set it equal to 0, factor, notice the difference of squares, set up my sign table. Once I have that, find out my maximums and minimums and my intervals of increasing and decreasing. This question is not a challenging question, it's just very, very methodical. Now, looking at a graph. Here's my graph of the function. It's given to me below. It says, show that the critical points occur at -2, 0, and 2. If it's a show that question, -2, 0, and 2 are my answers. So looking at the original function, I want to take the derivative. And my derivative is x cubed minus 4x. Again, I want to set it equal to 0 and factor. Again, x squared minus 4 is equal to 0. The x stays, that's x minus 2 and x plus 2. So x is equal to 0, x is equal to 2, and x is equal to -2. And there you have it. I now have shown that my critical points could occur at -2, 0, and 2. Fantastic. It then says, hence, so once I have that, determine the coordinates of the local maximum or minimum. Well, because they've given me a graph, this becomes infinitely easier. I look at my graph and I find f at -2. So I go up, I look at my graph, f at -2 is here at -7. So that's a -7. I find f at 0. F at 0, according to my graph, is at -3. And f at 2, again, is at -7. So the coordinates, as the question asks for, is -2, -7, 0, -3, and 2, -7. Be sure to answer the question that the question is asking as opposed to the one that you think it's asking. Pretty simple sort of understanding. Looking at the graph below, it says here, for the function on the previous page, what are the absolute maximums and the absolute minimums? So if I look at the graph, the absolute maximum is here, and the absolute minimums are actually the same on both sides, here and here, because this is a symmetrical graph. So the absolute max is at 0, -3, and the absolute min, you can either write it as 2, -7, and -2, -7, or if you feel inclined, you can say plus or minus 2, -7, like this, whichever you prefer. This is actually better. This is kind of lazy. And then it says here, suppose we now restrict our function to the domain -1 to x, x to 1, which means that I'm now just looking at the graph from here to here, -3. So from here to here. I'm only looking at this particular portion. It then says, now looking at just that, can you tell me the absolute max and the absolute min? Well, the absolute max stays the same. It's at 0, -3. However, the absolute min is only one of them. It's at -2, -7. The next question here, very similar. The only thing that's different, notice, is right here in the domain. The domain is restricted from -6 to 6, which means that when I pick values in my table, I can't pick numbers less than -6 or higher than 6. Try this question and see how you do. So if you've tried this question, you've taken the derivative, and I've forgotten a little prime there. Taken the derivative, you've set it equal to 0, you've factored, you've solved for x, you've drawn your sign table, you've chosen numbers, you've figured out what the intervals are, you've listed your maximums and minimums, and everything is on this page. Check your work, make sure you did just fine before you head to the next question. Now the next question is even more challenging. The reason that it's more challenging is right here when you look at the function. Notice that the function is a combination of two functions, 2x and root 5 minus x, which means that when I want to take the derivative, if I have a function times a function, I'm going to use the product rule. Also, looking at the numbers underneath the root sign, 5 minus x, I notice that I can't have numbers bigger than 5. Why is that? Well, if I do 5 minus 6, I get -1. I can't take the square root of a negative number, which means that all my numbers have to be less than 5, which is what I'm choosing. So everybody take the derivative. If you want, you can make your table. So f is equal to 2x and g is equal to 5 minus x to the half, like that. So f primed is 2 and g primed is equal to a half. So bring down the exponent, bracket to the new exponent times the derivative of the inside bracket. So another way to say that is -1/2, 5 minus x to the -1/2. That's great. Okay, now that I'm here, I'm going to write it out. So f primed of x is equal to f times the derivative of g plus g times the derivative of f. I'm here. I'm going to take out my common factors. Or I could simplify a little to make my life easy, because 2 times -1/2 is just -1. So I can do that. That might make my life easier. So I've got -x, 5 minus x to the -1/2, plus 2, 5 minus x to the half. Take out my common factor, which is 5 minus x to the -1/2, which leaves me with -x plus 2. A half minus -1/2 is just 5 minus x to the 1. That's 5 minus x to the -1/2. And in the bracket, I've got -x plus 10 minus 2x. So on top, I will have 10 minus 3x. And this here will go to the bottom to say root 5 minus x. Take a second. If you struggled with that a little bit, go over it. Make sure you've got it. Watch the steps again. Now, because I have a numerator and a denominator, the numerator will give me an answer. So that says 10 minus 3x is equal to 0. So 3x is 10, so x is 10 over 3. That's one possible critical point. And notice in my denominator, I need to know where it's undefined, so where it won't happen. So root 5 minus x is equal to 0. So 5 minus x is equal to 0. So x is equal to 5. So this is telling you, very carefully, please make sure that you understand, that this is undefined at x equals 5. So if I want to draw my table right now, I can draw it over here. I have 10 over 3 as an option, and I have 5, but it's undefined at 5, so I'm going to draw a hatched line. Because I did some thinking beforehand, I also know that I can't have numbers bigger than 5, so if I'm smart, I'm going to maybe shade in this region so that I don't accidentally pick numbers in that region. I'm going to have 10 minus 3x on this side, and root 5 minus x over here. Again, I'm now going to pick numbers. So let's say 0 is a good number, so that's positive. I'm going to pick, let's say 4. 4 is a good number, that's negative. Again, 0, that's positive, and 4, still positive. Positive and a positive make a positive, and a positive and a negative make a negative. This goes up and then down. Therefore, there is a maximum at 10 something. How do I find the something? I go back, 10 over 3. How do I go back? I go back to the beginning and I plug 10 over 3 into the original equation, and I should get out 8.6. My levels of increasing are from -infinity to 10 over 3. And my levels of decreasing are from 10 over 3 to 5. And we're done with that question.